So, here we're talking about rugged building materials, and so, we've talked about, already, how do we write good code? How do we deploy quality environments, and how do we choose our components wisely? And what else is left? And so there's some, when I look at security, I think there's sort of two sets of security tools. There are the security tools that are the prescription drugs. A lot of what we do in security is unfortunately correcting for problems elsewhere in the system. Not blaming people for that. That some of the vendors are the ones to blame for that. But a lot of security, if you go to a security trade show, it's it's prescription drugs to fix things versus healthy lifestyles. And so I would try to talk about some of the things that are the healthy lifestyles of how we build secure components into our infrastructures. And when I think this matters for a couple reasons. So one is whatever you call it, security and compliance matters. We'll talk on the next slide that how these are holding up the DevOps movements in certain organizations. And the other thing I think is important, one of the reasons I think, as Josh said, I agree that I think DevOps is a 30-year opportunity for security. We will never see a security opportunity like this again in many of our lifetimes, because so I ran computer security globally at General Electric, and as a overseeing an organization that size from a security perspective, one of the realizations I had that if you don't know what basically the visible ops principles, if you don't know what you have, how it's configured, and how it changes, building any security control on top of that besides crypto is pretty difficult. You have the house on sand problem. And the challenge is in security, no one in security owns configuration, asset, and change management. And the beauty is DevOps is cloud and DevOps are the first things that are fundamentally changing those how we do that in our enterprises, and that's a great thing for security. And so I get very frustrated when security people say, oh, DevOps, we're doing 3 deploys a day, I can't do a code review, that's horrible. And they're like, well, they're actually building reliable, repeatable infrastructure, which is the first step in doing security well, and so that really excites me. What frustrates me is when I see surveys like this, that CA did this survey last October, and security or compliance concerns was seen as the #1 barrier. I think 1,425 enterprise folks, largest barrier. So regardless of what motivation, Josh is, back to Josh's slides, whether it's hearts and minds, money, whatever motivating you, security is keeping us from getting this done in a lot of organizations today and moving forward. And I think one of the challenges is that I think we've talked about security has to improve too. This is not, hey, we've got security right. There's a breach a day. Our current approaches to security clearly aren't working. And so if the teams are coming in and saying, hey, you should take all the 20 years of best practice in security and build those in, I think it's appropriate to push back and go, wow, well, those don't seem to be working very well as it is. And cloud was a big prover, of that. I think in almost all cases, DevOps has a cloud component to it. And I think one of the challenges the security teams have, they're having trouble dealing with cloud. So even before you get to the complexities of continuous deployment, just the fact that this exists in a public cloud environment or an environment where you don't necessarily trust the systems administrator, there are issues like security, data sovereignty, and compliance that are dragging on our cloud deployments. And if we're dragging on cloud, we're really going to be dragging on DevOps. So we'll talk about some of the components today of how we can get through that. So Josh put up a picture in his presentation this morning of kind of the left-hand side of this. This is from a presentation he and I did a couple years ago, that the left-hand side sort of maps, again, the security controls. So network security, host security, that tiny little line of application security, data security, identity and entity security, and some rough views of the size of how much money spent. And then on the side, if it's hard to read, but that basically platform as infrastructure service, platform as a service, and software as a service. And when you look at where the security office spends their dollars in most organizations today, it's the bottom layers of this stack. You go ask firewalls, intrusion prevention systems, antivirus systems. You can't send, Heroku a firewall. Doesn't really work very well. The tools that our security teams are used to building and deploying have to change. And the good news is, if they change up the stack, it actually works fairly well for microservices, and it actually makes us more agile. That one of the big challenges that we have in general operations is that we end up too tied and too bound to the infrastructure that we're running on. And containers and microservices are excited because they bring a portability that if there's an outage or if there's a more attractive environment to run inside of, we can move our code. And security has been horrible to port. If anyone's ever been through the migration of a SOC or a firewall or an internet connection, our traditional approach to security were not very migratable. If we actually focus on the higher levels, we actually have a chance to not only do security more efficiently, but also to make our infrastructure more portable as a whole, which I think is very exciting. So I think one of the things important is building bridges. One of the talks that Josh and I recently did was talking about how security teams could build alignment across the organization. And the CTO and the DevOps team was one of the case studies inside of that talk. But we talked about a number of the different areas. And one of the things that as I look at the DevOps opportunities is. Our security teams want automation too. They might not know it yet. You might need to educate them. They might be saying different words. But if we look if you were to give your security team requirements for them to work in your environment, we want things that are orchestratable. We want things that are API driven and provisionable. That the security can be automatically assessed. There doesn't have to be a human who comes in and reviews and looks at this and said, hey, is this okay or not to deploy? The change advisory board. It should be automatable. It should be portable, and it should be risk-based or appropriate. I think as we get to crypto, we'll talk that a lot of security standards don't take risk into mind. And the idea, I thought it was fascinating this morning, you're talking of the average life of a container being 0 minutes or 1 minute. The idea, I've had this conversation a lot of times in big data environments that you're saying, oh, well, you're working with customer data, and you have to have these 17,000 controls before you can deploy this. You're like, well, I'm going to take this data, I'm going to spread it off to 1,000 machines. The attack surface will be there for 1 hour, and I'm going to turn it off and delete it all. The risk of that being live for an hour versus into perpetuity is very different, and we should force our teams to think differently. When you talk to the security team, they're saying, well, I want my security closer to the data. That protecting random infrastructure is not stopping adversaries. So protecting what matters where it matters is important. Cost of compliance. So part of the reason I'm a vendor now, I've been a security practitioner, both at the operational side as well as a security officer. Compliance is the worst part of security these days. In many cases, security departments have become the chief compliance checklist officer, not the security or risk management organizations. There are trends across all of security about lowering the cost of compliance. That in many cases we're doing security like things like segmentation and in our data centers, not because it's the right thing for security, but because it reduces our PCI audit scope. The cost and both the time and cost of compliance is a big issue with security. Analyst productivity, much like that if you have experience in DevOps, you probably get 10 recruiter calls a week because there's not people out there. Security analysts are as rare. That's someone who actually understands security infrastructure, what's happening in an incident, what an adversary is doing. We have very few of these people, and if you go to a security conference, there's 80 startups that all they're doing is workflow to make the analyst more productive. Better inventory and asset management, more uniformity, taking complexity out of the environments, faster updates and patches to the Heartbleed conversation, and most security people, if they don't have this on their list, they shouldn't be working with you, don't want to be Dr. No. That most security people hate to say no. They have to, it's their job, but in many cases, but they hate to be Dr. No. And so when you look at these things, there's actually a lot in common. The big challenge today is that, and I'm one of the vendors that has some products that have this problem, is there's a big gap between this desired state and security running as code. I was talking with Shannon this morning that if you did internet security in kind of the mid-90s when the internet took off, the internet went from this toy to something that really mattered from a business perspective, but we didn't have any tools of how we managed and scaled internet security and website security. And people, I feel like we're in a very similar place now that we have things that matter. They are driving immense business value, but the tool sets haven't evolved to where the point where they have GUIs and have automation and the things that you need to make them work. And so there's a lot of, I think the security teams, I think Shannon's talk was great and how we need to bring these together to the security as code concept is something that needs a lot of work, and I would encourage your teams to get involved in. So what I want to talk about first is a couple of core security building blocks that should be part of your plans and as you architect solutions. And I'll go through them quick, and then we're going to dive into some more on each of them. So, so first, is identity. If you don't know who or what is doing things, or importantly, failed to do something, that failures are important. That's a very important attribute for understanding security implications. Controls on what privileged users and privileged infrastructure can do. I think particularly the Snowden incidents put a big focus in security on the privileged user. I think we're missing the concept of privileged infrastructure or privileged code. If you look at what automated deploys can do, there's privilege there. If you look at how we centralized infrastructure, if you control the AWS account or the VMware management layer or the storage infrastructure, you have immense control on both security and the operations of the organization. And so, separation duties and least privilege are important components in that. Encryption is something that has the higher in the stack has really brought back what crypto that really was in banks, big banks and big governments, the only people that used it. All of a sudden, we're seeing people, 10-person startups wanting to use the same encryption infrastructure because of the impacts that can have. We'll talk about roots of trust and how crypto plays in these environments. But crypto has a couple of different functions. One is what crypto allows you to unshare in a shared environment. So if you encrypt something and you maintain the keys, you can eventually put that in hostile territory and basically unshare that data. And that could be because you have internal separation that you don't want a database admin to be able to see customer information. It could be because of compliance concerns with your cloud provider, third party. You need to illustrate to your auditor that that healthcare data cannot be seen by an admin at the cloud provider. More importantly, when I hear people say, when I work a lot with customers in cloud, and they'll say, well, I don't trust Amazon or Microsoft. And what that really means is I don't trust the government agency that could compel Microsoft or Amazon to force to turn over my data. And then obviously the adversaries is that there is separation that can come if encrypted data is taken and there is not an access to the keys and crypto is well applied, it provides some strength and resiliency. And then I thought it was great that Adrian mentioned logging and auditing, that we need to have granular views of what happened. We have to realize things are going to go wrong. We're going to have incidents, and the ability to understand what happened, remediate them, and learn, and to not repeat them. That logging and auditing data is important. And I think there's a big opportunity to automate the demonstration of compliance. This is an area where, again, I turn off when people talk about compliance. But if the data we have, auditing is an incredibly manual process today, and if one of the best ways to build a best friend in security is to automate something that an auditor is making them manually do today, you'll have a friend for life. So there's a number of reasons we need these components here. So as you look at identity, there are a lot of solutions for humans. There's a traditional space called identity and access management. I call it the ERP of security. It's immensely complex. You have vendors like IBM and Oracle and CA that have these ERP-like systems that take data from HR and contractor systems and put roles and provision that out. Those are sometimes useful. There's a new cloud IAM space that's much more that's much more provisionable and manageable. And the good news is, a year ago, if you were talking about provisioning APIs with these folks, the answer was, oh, put this in Active Directory and we'll key off from there. And in the past year, they've gone from this kind of enterprise directory approach to, oh, here's how our solution can be provisioned. Here are APIs for managing it. There's been some great evolution in this space. And one of the things I always encourage folks is solving identity for everyone is a really hard solution. Solving it for the privileged users is a really good place to start. That he or she you could deploy is God if that account is not well managed. If you have a shared root account doing deploys, that's a problem. So this is a great place, a good easy place to start. There's a lot less solutions out there for system services, processes, and things in the Internet of Things. I've been talking to folks about how do you do device ID management when you have 1 million devices in the Internet of Things. This is an area where there's not a lot of off-the-shelf solutions today. A lot of the identity vendors will tell you their stuff works. I think you'll find that to be not always the case. The good news is we need UUIDs or something similar for pretty much everything we deploy. If you're going to deploy and manage 1,000 of something, you need to be able to uniquely identify it and find it. So we have some principles here that we can work off of. And what's also to understand is understand privileged code. That if we have things that that a code can hit go and deploy or undeploy, that code has as much power as a privileged user. And so understanding those identities and so looking at the credentials to the kind of your modern production stack tend to be a great place to start. That the amount of people that I've seen that have spent tons of time on AppSec and then are doing massive deploys in AWS and then have a common bad password for all their AWS accounts and even turn on multi-factor authentication. That if you can control the production stack, you win. It doesn't matter whether you wrote good code or not. So the production stack is an important place to look and manage identity first. One of the things that actually amazed me as I was preparing for this presentation is, there's been a lot of talks around the DevOps community around secret management, and there's a bunch of products and open source projects that call themselves secret management servers. And what surprised me, I couldn't find anyone that actually wrote a good definition of a secret. And I need to work on. I want to work on one myself, but. I think some examples of secrets. I think everyone knows an encryption key is a secret. Passwords are a secret. API keys, tokens, anything that you want to keep hidden from someone else is a secret. And we need to manage those things. And some of the questions to ask is, where are we storing our secrets? Where is it used? Who or what is authorized to use it? And what is it authorized to do? And that lets you then have, to the misuse cases comments, have checks to make sure that these things are used the way they're supposed to. So before we talk about what you should do, let's talk about how how not to protect the secret. So the first thing you shouldn't do is embed it in source code. And bonus points if you embed in source code and then post it to Git. Git search, when it was rolled out in 2013, was one of the greatest tools for security red teams because you just search for begin RSA private key, and you'd be amazed at the number of things. It's better now, but in 2013 it was a gold mine of encryption keys. Adrian mentioned API keys. Amazon has had to have and other cloud providers had to have programs that actually examine public repositories because their customers keep posting their keys. So it's funny, but it's too real. Some people go, oh, well, I'm not going to put it in my code. I'll put it in a configuration file or script next to it. Same problem. And the other thing is, that people try to be more creative. And one of the things we'll talk about is doing crypto wrong is almost worse than not doing it at all. That they'll take the key and obfuscate it or embed it or hide it somewhere, and you create operational challenges yourself, and you really don't improve security. So if you're doing any of those things, please go back and fix that. So how do we protect a secret? This is long. I won't read it. It's in the slides. It's posted. Conjure is a startup in the U.S. that's he's building these secret management servers, and I thought they did a great job. I have no affiliation with them, but as I was doing the research, I thought they did a great job of defining how you protect a secret. Self-auditing, granular controls, encrypted when it's at rest, unique keying, a number of very important attributes to it. Professionally audited crypto, so real quality crypto. And one of the things I'll add is that one of the most fun things you want to mess with your security team is to argue about how you protect the secret to the secret server. that there is a secret that is a recursive problem. Ultimately, you need to authenticate to the secret server. And in addition is that these distributed secrets, if you can derive them, those UUIDs are great mechanisms, that they should have least privilege. And so you shouldn't have a common, if you shouldn't have one key that can open up, can allow every instance across the enterprise to take something and cause an action. That being able to make this granular is one of the key things. But if you want to mess with the security team, the recursive secrets to the secrets is a fun conversation. So how do you manage these things well? So in the first, a lot of people go try to do it yourself, and if you don't know what you're doing, don't. But I have seen some DIY things that I put one of them in cloud solutions. Seen people that have actually done a really nice job of saying, what, a secret, something I can put in a file. I have object storage like S3. I have strong identity and access management controls around S3, and I have it's a service like Amazon's key management service that they built their own. They've rolled their own, and if you have the skill set and resources to do that, possibility. But I think the good news is there's a lot of other solutions out there that are coming that you don't have to. So there's the traditional crypto key management space, and during the day I work for Gemalto, formerly SafeNet. Gemalto's identity and data protection division, and we have a number of products here. And traditional key managers are really good at managing keys, manage life cycles, but they weren't necessarily API driven, as scalable as they need to be. With something I work with every day inside our organization is making sure we're investing to do those things. So you have to look. They're great for encryption keys, but what most people don't know is there's a standard called KMIP, the Key Management Interoperability Protocol, that was designed by the storage industry because the storage vendors didn't want to be in the key management business. And they would say, hey, how do we commoditize this and let people buy a key manager? KMIP has this concept called a blob. And so you can make pretty much anything a KMIP object. So there's the concept, even if you're not using KMIP, it's something that's really useful to look at because this concept of a unique secret or a blob that doesn't have to comply to an RSA key, private key structure, number of things you can do. Cloud solutions have come about. So Amazon has been the leader in this space. Cloud HSM is something that I've got to spend a lot of time personally with. Was the first time where you could actually put an encryption key in the cloud with a audited high degree of confidence that the cloud provider doesn't have access to that key. There's separation between the cryptographic function that the end user has and Amazon as a cloud provider, what they could do. Amazon also launched KMS, which is I think more of an infrastructure for a service for their services, as well as has application kind of REST APIs for applications to use. There's the AWS S3 approach we talked about with their IAM system. One of the concerns you have to be careful about is we talked about portability. If your service offering comes from your cloud provider, you have to understand how you would switch later. KMS does not make it very easy to take your key and do something else with it. Cloud HSM allows you to, as long as it's to another SafeNet HSM in the same security configuration, which is also a pretty high bar. Microsoft has rolled out Azure Key Vaults, very similar. So the great scale and management, not just portability. And there's a ton of other solutions. Conjur, that I mentioned, has a secrets manager. HashiCorp has built a product called Vault written in Go that's pretty exciting. It's early, but very exciting. Square open sourced their KeyWiz solution, which basically it treats secrets as files. Pretty innovative approach. Barbican is part of the OpenStack initiative. It was originally designed as a shared secret manager for the OpenStack infrastructure, but what we're seeing is people evolving that infrastructure, starting to use that for other non-OpenStack services. So there's some innovative development going on around Barbican. There's some Chef Vault projects. There's some pretty interesting things. What I say is, know your capabilities and your security needs. We're going to talk about crypto assurance levels on the next level. Cloud HSM is the highest security crypto model you can have in the cloud. It's also one of the most expensive and the most constraining architecturally. Whereas KeyWiz, but I think some people would say has some security concerns, but it's not designed for the assurance level. If you look at what Square has, Square also has a product called Bletchley that exposes their HSMs. So understanding what products you need where is important. So one of the things about crypto is, crypto is scary. That's right. Crypto is one of the few places, you can easily shoot yourself in the foot. If you encrypt something and lose the encryption key, you've self-destructed your own data. So that's really useful when you want to put data in the cloud and you decide you're done with it. You just want to delete the key and not worry about the data lifecycle. When you wanted that data, doesn't make for a very good day when you have to explain that you lost all the data. And there's and the other issue is a lot of people spend a lot of time deploying crypto and then miss key management, important key management principles, and end up having encryption implementations that aren't very valuable. So the beauty of crypto is it's the one security control. Again, if you take encrypted data and put it in hostile territory, you have a mathematical reliability of that data, based on the research and implementation of it. So very useful control, but has to be implemented properly. So and by the way, all these topics could be full day workshops. So gone through these at a high level. Be happy to dig in more offline. This is a really important concept to understand, and again, you can dive in more. But if you look at encryption, the idea it comes back to what is the quality of the encryption key and the encryption implementation. So there are things they call trust anchors. So hardware security modules are probably the most common. So HSM, say the AWS Cloud HSM. There is trusted platform modules in laptops and servers, the TPMs that have some of these functions. But the idea of an encryption of a trust anchor is it's something that can create. First thing it can do is it can create a high quality encryption key. So that often means a certification authority has said this is actually a true random number generator. Post Snowden, I had to talk more about number generators than I ever care to. But you get a high quality encryption key. And then you have some options to what you do with that. That if these things can vault a key, they can hold a key in here where that key is never exposed. And that's, you'd think from a high assurance model, you have a key in a safe, and if you want to use that key, you have to send the data to the key to be used. Very high assurance can be architecturally constraining. These things are fast, but they're not between your application in memory and flash flash drive fast. So there's some but that doesn't mean you can't use them. So the idea that on the right-hand side, this high assurance model where the application or workload uses the key in the HSM or in the trust anchor, is a important model for high assurance models. And if someone comes to you and says, "Oh, I need a FIPS 140-2 level 3 implementation of crypto," this is what they're talking about. The good news is you can actually chain keys to get some of these benefits without requiring the same architectural concerns. So if you look at a lot of those secrets management projects, what they'll say, "Oh, well, we'll take every secret you have and we'll encrypt it, and we'll store it in some sort of management layer. And then we'll take that layer, that encrypted key, and we'll encrypt it again down here." So now you get the key generation quality and the ability that you can delete one master key and have the entire hierarchy disappear, but that you can actually deploy keys out to applications, to microservices, at the workload level. So there's a number of different ways that crypto can be deployed, and you'll hear concerned people say things like FIPS levels from the US government to become kind of the international standard for how these are rated. And there's level 1, which is a software implementation. Level 2, which can be achieved in software on a reference architecture, but is generally done in hardware. Level 3 and 4 that are hardware-only environments, and you can mix and match how you handle these. But the key to this is understanding what are what level of security do you need. This is incredibly valuable, but can be also very expensive. So, switching on to logging and auditing, this is one of the areas where I think most people consider boring, but it's something that's really essential to security. And it's a great starting point as we're talking about for the automated compliance conversation. That if you, as well as testing, if you can produce rich data, a security team should be able to do certain assessments just off of that logging data of whether it's deploys, configuration, environments. And this is a place I have immense hope for the DevOps community, because this is something that is core to what, if you're going to deploy something, you better roll it back, you have to have knowledge and ability to do that. And so this is a place where I think most both operations organizations as well as security organizations could learn. The question I ask is, are you capturing the key attributes? So the 6 W's: who, what, where, why, when. are you putting logs somewhere that is secure or tamper evident? So if you're logging and leaving them on the server in a directory accessible by the same user of the application, those aren't secure logs. So are you putting those someplace that you can prove that the logs are the logs? And this is a place where, again, I think we can work to automate a number of the security tasks today that are incredibly manual and painful. And so this is a place I think there's a lot of hope. It's actually one of the areas when I'm talking to security teams about cloud, the opposite conversation is to tell security teams this is where they should, if they're not doing cloud, they should start, is take all your logs and stick them in the cloud. That everyone's security complains they never have enough data, never have enough log data, they don't know what happened, they don't have enough storage to keep it, they get 15 days of logs, they need 6 or 12 months to go back and find attacks. So this is an area where I think there's a lot of commonality in what needs to be done. So in closing, I always like to end with sort of an apply or takeaway. How can we walk out of here and make an impact? So I think first, finding common ground with the CISOs on security and compliance automation, that we all want to take, none of us have enough time to accomplish what we need, and we all want automation. And so I think it's a great common point to say, hey, we may not agree that whether or not something needs a code review before it goes live, but what can we take and automate today that makes all of our lives easier? Focused on the privileged users infrastructure, that if it can commit, decommit, create, delete, the things that have the largest impact and the widest reach are a great place to if you have a secret, make it one. One of the areas, the security perception of the DevOps community is that there's not a lot of discipline around secrets, and I think there's, whether it's true or not in your team, there's a lot of examples out there that support that. So if you have a secret, make it a secret, and don't take crypto lightly. One of the beauties of these cloud services for crypto is that 5 years ago, to do crypto, you had to be a crypto geek, and no one can afford to have a crypto geek embedded in every team. Now, there are services that are API driven that are enabling you to do this better. But if you do it well. And I think in closing, making security portable, that's something your security team has to do with you. But the idea, if we can make security portable, we can actually make security more agile as we move along. So I think there's a ton of opportunity, and hopefully these components you can see some ways that take home and build bridges and improve security today. So thank you very much for your time, and look forward to the panel.